All right, we are in chapter 1. This is part 2. This should line up pretty much with your second set of notes. We're kind of at the nature of environmental science. We should already have some sticky notes from our first set over on here. As we flip the page, we have what are the lessons of Easter Island. So we read this the other day in class, and from this, the biggest takeaway is this is an example of tragedy to the commons, where you have a group of people or a civilization that uses up an entire resource and it's no longer available, and usually can have some dire consequences. So they give some other examples like the Polynesian Islands in here. They talk about rat infestation. Make sure you kind of have a good idea of this story and also what it means to be a tragedy of the commons. All right, time for some sticky notes. In this first section, environmental science is an interdisciplinary study. It mainly means it's made up of lots of different fields. So we're going to do a little bit of biology, some chem, which you guys are familiar with. We'll go into some ethics and talk about, if we're talking about population control, we're not going to just kill everybody, okay? We don't believe in genocide. We will do geology and talk about the age of the Earth and how the Earth has changed over time. We'll do history, political science. We'll do actually a lot of politics and talk about how our laws and policies, all of that changes and affects that. You do not need to know all these. You just need to know that environmental studies has a lot of different disciplines. Natural science versus social science. Natural science, you are studying the natural phenomena, okay, like biology and chemistry. In social science, you are actually looking at and knowing the science behind people and their effects. So a social science would be a lot more like engineering or economics or political science or even history. Natural science is anytime we're studying just the phenomena of the natural world, more so like oceanography or geology or biology. Some of these end up being both. Anthropology is the study of humans, which is definitely social, but it's usually definitely also has some natural parts to it as well. It's usually extinct cultures or cultures that we're just not very familiar with. Okay? People vary in how they perceive the environmental problems. Okay, so this has changed over the course of the 20th century, mainly due to time. You might already have the sticky note in here. Rich have a very different perspective than the poor on how we should use our environment, what we should do with it. If you're in a poor community, and we're saying poor, but realize poor doesn't necessarily mean bad. For example, we used to think that the Native Americans were a very poor society, but they were very one with nature. They weren't having a large ecological footprint. They didn't have a lot of detrimental effects. Okay, so rich versus poor will have different environmental impacts. It changes with time as well. So the example that they're giving here is you have this woman who's spraying DDT in this little tiny girl's face, which is a pesticide. They're doing so that she stays nice and healthy and doesn't have lice in her hair or doesn't spread lice to other children. Lice used to be a much larger problem. It still is today. The problem here is DDT being a pesticide is definitely a carcinogen, something that they did not understand in the 40s and 50s. So at that time, this was very harmful. They did not know that though. Okay? Also, I hate the sound of my voice. That's why I didn't do some of these. And I will encourage you guys to listen to other teachers as well. Environmental science is not the same as environmentalism. We definitely need to know the difference between these two. Environmentalism, okay, is kind of like peace and loving and you're one with nature, okay? It's someone you would probably call a tree hugger, someone that is advocating just for the environment and not necessarily looking out for what's the best human actions, okay? They might not be looking out for corporate America or our economy. Environmental science is the study of the environment and all these other disciplinaries. So these two things are very different. This is a little bit more hippy-dippy love, okay? And this is definitely a science where we're going to need to have data, okay? Simply liking the environmental science and being one with nature and enjoying our beautiful environment is not necessarily environmental science. This is going to be studying, hypothesis, testing, data-driven, and all these other disciplinaries that we talked about over here, okay? Over here we get into scientific test ideas by critically examining evidence. Here we're getting into the scientific method. So we have observational science versus descriptive science. We actually might want a sticky note for that, making sure we kind of understand those two. Okay? I just put this one up here. That's my car. Okay, I drive a Chevy Volt. Every day I plug this into my garage, and I get about 60 miles in the summer and about 40 miles in the winter, depending how cold it is. It also has a gas engine that I can use in case we run out of electricity. The reason they have this picture on here is right here. Science knowledge can be applied to technology. Okay, this is definitely a growing field. Making anything more eco-friendly, more environmental friendly, better technology. And the other thing is this saves me a lot of money. So that's a big thing. People are concerned about this, and it is right back into engineering, political science, economics, all of these things here. Okay. Right here we have someone that's doing a prescribed burn. Okay. Prescribed burn showing how in the National Forest, I'm not going to pronounce that word, is managed a practice to restore healthy forests. Okay, so we've had a policy here in the United States where we've asked you to stop forest fires, and that's Smokey the Bear doing that. And in doing so, we have a lot of undergrowth that has built up, and we have lots of leaf litter. We have lots of trees, all in an area, because forests are supposed to be somewhat natural. As all this material builds into an area, if you did have a forest fire that occurred that hasn't happened in a long time, the more litter you have in here, the larger your forests go. And that can be very dangerous. If you have lots of undergrowth and lots of litter and lots of fuel for a fire, if that goes up and we're not expecting it, it can really go through an area very quickly. So prescribed burn, you pick an area, they normally do this in the wintertime or in a very wet month, and they'll burn a lot of this material. And they'll do so if we get a fire, it won't fly through there and pretty much burn down homes and people's houses. Okay? That's Mr. Who's car. That's what that says. Okay. We then get into the scientific method. Okay, so for this, you definitely need to know the steps to the scientific method, which are right here. Make sure you have these filled into your notes as well. We want to know this order as well. We have an observation, usually of something we're observing in nature. We propose a question. We then make a hypothesis. Okay, and it's a hypothesis driven. Normally, we do this in the form of an if-then statement. So if our independent variable increases or decreases, then our dependent variable increases or decreases as well. We'll talk about this in a minute on the next page. We will either reject our hypothesis, meaning we were wrong, or we will fail to reject our hypothesis. We never say our hypothesis was right in science. We're not sure if we were right. All we are saying is that our evidence supports what we thought. Okay? It's basically kind of the opposite of dogma. Dogma is the idea of we are definitely correct, we know we are right. Scientists, we are fairly humble, we don't know that we are right. We either reject our hypothesis because it didn't support it, or we fail to reject. Okay? We'll form a test, we'll get our results, and this always comes back to your hypothesis. Next up. Developing a hypothesis, making predictions. Here's our important part, testing your predictions. Okay, so when we have an experiment, we have lots of different types of variables. We have an independent variable, a dependent variable, and we have a control or a controlled variable. Independent variable is the one thing you change in an experiment, okay, and you only want one of these. If we're doing something, say, with plants, okay, we wouldn't want to change the amount of water, the amount of fertilizer, and the amount of sunlight, because we really wouldn't know when we get our results, like of our plant growth, what thing really had the biggest effect. So anytime you're doing an experiment, you want one independent variable. So in here, let's talk about fertilizer. Okay? So if we were changing the amount of fertilizer, everything else we'd want to have stay the same. So if we're using the same type of plants, the same amount of water, the same amount of sunlight, where we place those plants, those would all considered be controls or controlled variables. Dependent variables, you can have more than one. So we can measure the height of the plant, the health of the plant, how long it lives, how many seeds it produces, how many flowers it makes. Dependent variable has to be measurable, okay, but you can have more than one. I think we're pretty good on data analysis and interpretive. We'll get into some stats stuff. If you're taking a stats class, you'll know a few things. You do want to know qualitative versus quantitative. Okay, so a quantitative has to deal. This should be a sticky note. Quantitative would mean you're using numbers. Okay, qualitative would just be an observation. Those plants look healthy. Those plants look sick. Those plants didn't grow. Quantitative would be like weighing out the plants to get masses of each single one, or counting the number of seeds. Okay, make sure we know qualitative versus quantitative. We can test hypotheses in different ways. Okay, we can have a manipulative experiment. This is pretty much what you guys are familiar with, where we pick one variable and we're probably testing it, say, in a classroom, and we can definitely control a lot of the things that are happening. We could also do a natural experiment. When I did my master's degree, I worked with trees, and I basically was comparing trees growing at different latitudes. I didn't really get to pick that. I had to move to those different locations and then also measure the types of trees that I was working with. That would be considered much more of a natural experiment. With a natural experiment, there's a lot of things that could potentially be outside of your control, as far as environmental factors, sunlight, whole bunch of different things. But I basically moved up and down through the state of Michigan, and depending how far north I was versus how far south, that was my independent variable. And then my dependent variable was the growth of the tree as far as how tall they were, the diameter of the tree, and also species. And I'll talk more about that in class as we do some ecology-based stuff. Another big part in here is real science has to be peer-reviewed. Okay, so when anyone does a master's degree, a doctoral, you're doing peer-reviewed research. As I wrote up my paper to be published in a scientific journal, that first had to be sent off to other people and other doctors within ecology or environmental science, and they had to look through there and provide feedback to me. All of them provided stuff that said, hey, there's a few things that you're missing here. We had to go back and think about some of the variables that you've missed. So after I sent out the first one, I did have to go back out and fix a few things that I had missed, which is peer reviewed. Okay? Anytime, and you guys will kind of get into this once you move into college. But peers that understand the material, that are highly qualified, will have to read through your journal and make sure you don't have information that could be biased or wrong or misleading. Okay? And here's kind of a continuation from the other thing as far as how all of that works. It's a very tedious process. Bloop. Grants, funding. What I want you guys to know from here is mainly the bias of funding. So my example that I have here is the health food industry. Okay, for years, if a research paper was done by, say, a sugar company, they're going to tell you and find research that supports the idea that fat and dairy and meat are probably not as healthy, and that sugar is not a major problem. Okay, if you have a scientific research project that was done by a dairy institute, they're probably going to find results that will line them up that will make them sell more dairy. And they'll probably say that sugar is the worst thing for you. If you are having a scientific study, for example, the tobacco industry for years has basically said, we're inconclusive on the health studies of smoking. Especially, and we now know that those studies were very misleading. They were not correct. Okay, smoking is definitely unhealthy, definitely causes cancer, both lung cancer, mouth cancer. You'll lose your teeth, you can lose your gums. But the smoking industry was trying to find research and grant and funding and provide evidence why smoking is not that bad for you, because they want to sell cigarettes to you. Okay? Don't worry about paradigm shifts. That is not that important. Okay? We're not going to find that on the AP exam. We're getting into this into the next section. We'll do a little bit of it. Sustainability in our future. Make sure you know what it means to be sustainable. Okay? Understand that populations, the larger your population is, the less sustainable you are. Make sure you understand consumption. The more a population consumes goods, products, makes things, the less sustainable you are. Okay? Sustainable is the idea of having ecological availability for our offspring, as far as having a clean earth, clean water, clean, breathable air, and real ecosystems. Over here, we're comparing our ecological footprint comparing to different countries. Okay? World average is about 2.7 hectares. Okay, so let's talk a little about what that is. A hectare is 2.47 acres. Okay, and an acre, okay, is about 60% of a soccer field. So we have us here at the United States, 7.2 hectacres. Okay, your ecological footprint is very, very, very large. 7.2. Timing that by 2.47, 7, 14, 15, 16, 17. You're looking at about 18 acres, basically. Okay, which is 18 times 0.6. If I'm doing some basic math here, I'm going to cheat because I don't want to think too long. Later, I'm going to make you guys do this all by hand. Roop. Grab out your calculator. Let's get our exact number. So we got 7.2 hectacres. Okay. We're going to times that by 2.47. Okay. And we're going to times that by 0.6. So here, whoops, that's not right. Points times 2.47 times 7.2. Okay. We in the United States, your ecological footprint is about 10.6 football fields. Okay. You'll need to know the hectare number, and ours is definitely by far the largest in here. Hades is fairly small. Indonesia is not too bad. Even China, even though they have lots of people per person, it's only about 2.1. China simply has the largest economy. So overall, as a country, not the largest economy, we in China have the largest economies, but China simply has a lot more people. So because they have such a large population, you take all those people and times it by 2.1, then it's a much larger footprint. Okay? Getting this right into population. Okay? Definitely know that the U.S. population is about 327 million. World population is at about 7.5 billion. Okay? And these numbers affect your sustainability and also your consumption of goods. Then we're going to get into energy sources. Make sure you know the difference between fossil fuels, renewable, and I'm going to add on to here nuclear energy. Okay? We can divide this up a lot further. We'll get into these, but how we're using an energy source will definitely affect our sustainability as well. We also have on here sustainable solutions. So for on campus, we are going to refer to this as far as like our campus here at Bloom High School, and campus sustainability. So things that we do well, things that we don't do well. We do recycle paper. Okay, we create a lot of garbage down in our cafeteria. We do not currently recycle plastic at our school. We have lots of water bottles that we sell. Okay, there's some bad things about sustainable. There's some good things. With the recent school improvements, we have LED lighting. They redid all the ceiling tiles. We just put in more air conditioning, which would technically be bad, but it's better controlled. Okay? So right there, we're going to stop there for today. That's enough of our sticky notes. And then we'll kind of talk about these in class.